This topic will present the basic flow of Spirent TestCenter Automation. In the previous topic, we discussed the syntax as well as key elements of the Automation API. Within the basic flow of Spirent TestCenter Automation topic, we will build on this knowledge and present the steps necessary to code a basic script. When you're going to create a script, it's going to contain initialization. You will connect to the Spirent TestCenter chassis and reserve your test ports. You will create the object hierarchy. You will establish a subscription for test results. Apply that configuration. You will start the analyzer, the generator, and capture. If you're going to use capture, you will transmit the traffic. You will stop the analyzer, generator, and capture. You will gather test results and then release the ports and disconnect from the chassis. Initialization contains loading in the Spirent TestCenter API as well as creating any equipment or system variables. The first piece is to perform the package require Spirent TestCenter. That's going to load in the API. You'll notice we performed a put-s statement after that to inform us within the script that that step actually happened because now we were past that initial package require. We also perform a package required for SQLite 3. Now that's going to be used later on when we're going to access the database results. And also we put a put-s displaying that that package was successfully loaded. Now you'll notice that we're setting up some hardware variables. We're setting the IP chassis address as well as setting up the variables for the transmit slot, the transmit port, the receive slot, and the receive port. Now we will use these later on in some of the commands, and rather than hard coding those values within that command, we will just perform variable substitution and call these values into the script at a later time. The STC Connect API function establishes the connection between the script and a Spirent TestCenter chassis. Very simply, STC : connect and then the chassis IP address. Now you can find the syntax for the STC Connect API function in the Spirent TestCenter Automation Programmer's Guide. Now in our example, we'll see that we performed a put-s, we're connecting to the chassis, and then you'll notice we did a $chassis IP, so we will display that we want to connect to chassis 63.171.237.132. And then you'll see underneath that we perform the STC : connect $chassis IP. That will also use that IP address. There you see how we're not hard coding that value. This way, if you're ever going to port these scripts somewhere else, it's going to be very easy to make one change at the very beginning of the script rather than having to change it throughout the script. The STC Reserve API function reserves one or more ports on one or more Spirent TestCenter chassis. When you reserve a port, your test session has exclusive access to that port for the purpose of running a test. You'll see here in our example, we perform a put-s stating that we want to reserve the chassis, the slot, and the port, and then we actually perform that with the STC : reserve $chassis IP, transmit slot, transmit port, and then we do it for the receive slot and the receive port. Your script must contain a project object. Now, the system object will be created for you automatically. However, you will have to create the project object using the STC Create API function. You can only create one project object within a script. When created, the project object is automatically placed under the system object. You will create port objects as well as other objects under the project object. The project is directly under the system. You're going to use that to build your hierarchy down from there. We're using a put-s statement just to say, hey, we're going to do this, or you may want to put the put-s statement after the function is performed, but then you'll see we perform a set h project and then square brackets, which is command substitution, which means that the STC : create project will be processed first, and then the handle or the return value will be placed into the variable called hProject. Now we have the handle of the project that we will use later on within the script. The next step of the script is to create test port objects so you can generate and receive traffic. You will use the stccreate API function and the port object to create the logical ports. You will create the port object under the project object. Remember the hierarchy. You must map these logical ports with the physical ports that you reserved on the Spirent Test Center chassis. 2 slides ago, we reserved ports 3 and 4, and now we're going to create these logical ports and map them to these physical ports. You'll notice in our example, we perform a put S, and then we are going to create 2 ports. Handles are going to be H port TX and H port RX respectively. You'll notice that we are creating them under the project handle of H project. We're using the $sign because we want the value of that handle. The location, it's identifying the chassis IP address, and then the transmit slot and the transmit port. So that's going to be slot 4, port 3 for transmit, and slot 4, port 4 for the receive. And use default host is setting the value to false because we are not going to use the default host. Now, just to prove to you all of the default attributes that were created for this port, we're displaying a snippet of code that we added to the script, a little procedure called P. If we specify a particular handle, it will then go in and perform a get on that handle and then basically look for all the children of that handle. When we call it P $H port TX, it's going to display everything. And if you look more towards the bottom end of that, you'll see the supported physical interface is Ethernet copper. Also displayed in the right side of the screen, the supported physical interfaces that are supported from the documentation, and you'll notice the default is Ethernet copper. Now, if we wanted to specify something like Ethernet fiber or Ethernet 10 gig fiber, we would have to specify that when we created the port, or later we could go in and configure the port and change that value. Just wanted to show you that even though you did not specify a value, one was selected or specified for you automatically utilizing the default attributes of the objects. Once you've created the ports for the test, now you must use the stcperform API function to call the setup port mappings command object to map these logical ports to the physical ports. Now remember, you will find the syntax for the setup port mappings command in the Spirent Test Center Automation object reference document. This is an object. That's why in the perform is an API function. So you're going to perform something. You're going to perform this object. And you must send the configuration to the hardware using the stcapply API function. In our script example, that when we are attaching the ports, we are performing the setup port mappings. Now also applying the configuration. Anytime you specify stc::apply, you are going to push the configuration that you have within the script down to the Spirent Test Center chassis. Moving down the object hierarchy, now you will configure the traffic stream blocks under the port objects using the stccreate API function and the stream block object. A stream block is a template that describes the definition of the stream. The stream block configuration object template provides the options for configuring stream blocks containing different source IP and MAC addresses, destination, MAC IP addresses, etc. You are going to define the stream. Now, if you are not configuring a stream block from scratch, then you must specify the -frame config attribute using the double quotes. You open a quote, you close a quote within the configuration. Failure to do that will provide unpredictable results that you do not want to follow. Now, we have an example of this on the next page. You'll notice here we're specifying a put S command that's going to display that we're configuring a stream block. Then we're going to create the stream block. We are going to return the value, the handle, and store it in H stream block for further use. You'll notice we are creating it under the transmit MIT port. And you'll notice that we have the dash frame config, and we're also specifying the fixed frame length of 256. In the next piece of code, we're going to add some header information. In this case, we're performing a create, and we're creating an Ethernet 2 header. We're going to create it under the stream block, and then we are going to specify the source MAC and the destination MAC. Now we are going to perform the STC perform stream block update, and we're specifying that we want to update a stream block, and that, which one do we want to use? Well, the one with handle H stream block. And then we perform a put S command, stream block configured. Now we will move on to the generator. The generator object will transmit the traffic created by the stream blocks. And you will specify traffic properties such as load, how long you want to run the traffic, scheduling mode, what kind of scheduling do you want, within the generator config object. When you created the port object, the Automation API automatically created a generator object and a generator config object. You will need to retrieve the generator object handle using the STC get API function first, and then the generator config object handle before setting the generator configuration. Maybe a little confusing. So to say this again, at first you're going to get the generator object handle, and then you want to get the generator config object handle, and then you could go and configure the generator. Now when you're going to go in and configure the generator, you're going to use the generator config object. You will go into the Spirent TestCenter Automation object reference document and find the values, find the description, find what the attributes are, what you have to set, and what is set for you automatically. Here's our snippet of code. You will notice the first thing we do is obtain the generator handle from the transmitting port by using the get API function, and then we are looking for the dash children, and we're looking for generator children. That will return the generator handle. Then there is an STC perform generator stop. So we are stopping the generator, which in effect will reset everything. And then we perform a put S statement that will display the current state of the generator using the STC get command. Then in the next bit of code, we are obtaining the generator config handle using the same process. Only instead of going from the port, we are looking from the generator handle. Then you'll see the STC config, and then we're specifying the generator configuration handle. Then we're defining some of the attributes. There's really two schools of thought here. Some of these attributes are default attributes, so therefore you do not have to set them, such as the load mode of fixed or the load unit of % line rate. Those are defaults. If you looked in the documentation, you would see that. However, some schools of thought would like to see what's being specified. Others, they do not want to write the extra code. It's really up to you how you want to manage that. The duration mode is in burst, so we're going to be sending a burst of traffic. We're going to send one burst. We are sending 100 packets. The load mode is fixed, meaning that it's going to be a fixed rate, and it's a percentage of line rate, and the scheduling mode is rate-based. Then we perform a put S stating that the generator is configured. Once you have set up your generator, you must now configure your analyzer. The analyzer object is used to analyze the results based on the options provided. Each port has independent analyzer filter setting. You can select customizable histograms that display in real time. You can also create custom 16 or 32-bit filters by specifying a specific location within the frame to filter on. Just as with the generator object, the script must retrieve the analyzer object handle, where you should initialize the analyzer object and then retrieve the analyzer config handle before setting the analyzer configuration. Here we are displaying the analyzer config object, or at least a portion of it, within the object reference manual. From there, it will display the things such as a description of the object as well as the attributes. We will then look at the code. We will see that we are going to start By initializing the analyzer, just as we did with the generator, we're going to receive the analyzer handle, or we're going to retrieve it from the port handle, which is the receive port. And then we are going to perform an analyzer stop on that analyzer handle. And then we'll display with the putS command stopping analyzer, and then we'll retrieve the current state with the get command looking for the analyzer handle and the state. Once that's completed, the latter part of the code will retrieve the analyzer config handle.
Thank you. This completes this video presentation.